A right circular cylinder of height 12 centimeter and radius 4 centimeter is filled with water. A heavy circular cone of height 9 centimeter and base radius 6 centimeter is lowered with vertex downwards and axis vertical into the cylinder until the cone rests on the rim of the cylinder. Find the volume of the water which spilled over from the cylinder. Also, find the height of the water in the cylinder after the cone has been removed. What we need to look at here is, first we need to picture how the problem look like. We're having a cylinder and the cylinder is of height 12 centimeter. That is, from this to this is 12 centimeter. And the base radius of that cylinder is 4 centimeter. So from this side to this side, so we can label it 4 centimeter. We're having another circular cone, which is, it is of height 9 centimeter and base radius 6 centimeter with vertex, that is the sharp point of that cone, move downward vertically into the cylinder until it rests on the rim of the cylinder. This is the rim of the cylinder. So we can assume to have a cone like this. And as this cone is, it is of height 9 centimeter as it is given, and the base radius 6 centimeter. So this height of the cone is 9 centimeter, the radius is 6 centimeter. We can label this 6 centimeter and this can be 9 centimeter. And we get to have it that it moves downward, so into the cylinder until the cone rests on the rim. Now the cone is resting on the rim. Let's not forget that the cylinder has a water inside of it. So it now happened that we have to find the volume of the water which spills over from the cylinder. By the time this cone rested on this cylinder, there will be water, there will be part of this that will be spilled over. This shaded part will be spilled over. And if we look carefully at that shaded part, we will see that it is like a mini cone. So we needed to find the volume of that mini cone. And that volume of that mini cone will be the exact volume of water that spilled over from that cylinder. So now to find the volume of this cone, let us look at it very carefully. To find the volume of the cone, we need the formula volume of cone, which is 1/3 pi r squared height. So we need the height of this little cone. And to get the height of this little cone, this is the height we needed. Also, we already have what would be the radius. The radius will be equivalent to 4 centimeter, because if we can see it from the point of the cylinder, we will see that the radius here is also 4 centimeter. So it is only the height we need, and we'll put it together to find the volume of the cone. Now, how do we get the height? Before we can get the height of this, we needed to use the given value, which is 9 centimeter and 6 centimeter. And what do we do with that? We use it to find the vertical angle of this cone. And when we find the vertical angle of this cone, let's not forget, half of the vertical angle here will form a right angled triangle, which can give us the height as it is relative to the radius, which is r, and the height we're finding. So what we do now is to find the angle. And to find this angle, let's not forget that this angle can be found considering this biggest right angle triangle, which tells us that tan theta is equal to what is opposite to this angle, 6 over, and what is adjacent to it, 9. So tan theta is equal to opposite over adjacent. So then we can have it that theta is equal to the arctan of 6 over 9. So, and this expression will give us the angle at this particular point, which is, of course, the angle to this right angled triangle that we just have here. So, and when we get this angle, we can use this angle to find its equivalent height to this radius, which is 4. And this radius will stand to be the opposite for this angle, while this will be the adjacent. So the expression of this, the simple answer to this will give us the angle. So, and by that, we can now take the angle again to have it that tan theta is equal to opposite, which is 4, over adjacent, which is the height, the little height we want to find for this little cone in order to find its volume. Let's have it h. So what next is that this can be h is equal to 4 over tan theta. Let's simplify to know the angle theta, then we can bring it in to know what the height of that little cone will be. So arctan of 6 over 9 is 33.69, and we now have the value for tan. We have the value for theta. So the height will now be 4 over tan theta, which is 4 over tan 33.69. So 4 over tan 33.69 is 6. So what we have as the height of that cone is 6. Then we can now use that to find the volume of that cone. So the volume will now be 1 over 3 pi times radius, which is 4 squared, times the height, which is 6. Okay, so we can now simplify this. When we simplify this, and that will be the volume for that little cone, which will also be the exact volume of water that spilled over, meaning we have been taking care of question A. So the simplification of this will be the 6 times 16 times 22 over 21. So the answer to that is 100.57 centimeter cube. So the spilled over water now is 100.57 centimeter cube. Now, to find the height of the water in the cylinder after the cone has been removed, we needed to find the volume of that cylinder. Then we'll take away the spilled over water from it in order to know the level of the water in the cylinder now. Because the level of that water in the cylinder will reduce, so we can now use that volume that remains in the cylinder to find the height as it is required. So the volume of a cylinder now is pi r squared height, which is 22 over 7 times the radius of the cylinder is 4 squared times, and the height of the cylinder that is given is 12 centimeter. So we simplify this to get the volume of the cylinder. So the answer is 603.43 centimeter cube. So that which we now have, we now take this away from that in order to get the remaining volume of water in the cylinder. So 603.43 minus 100.57. So this is the remaining volume of water in the cylinder, which we can now use to find the height. Let's not forget the volume of water is, the volume of the cylinder is given V is equals to pi r squared. So we have 502.86 is now equal to 22 over 7 times the radius squared times the height that we are finding. So we can now simplify to make the height the subject A. So when the height is the subject A, that means we will have 7 times 502.86 over 22 times 4 times 4, 16. So we simplify this to get the height. So when we simplify this, what we have is 10 centimeter. Don't forget it is measured in height, that is centimeter. When it is measured in volume, that is centimeter cube. Thank you.